Welcome to CS420 Lecture 8, where we're going to do even more recursion. So we have the BNF for an S list that we had from last lecture, and we're going to write more functions that operate on this. The first function we're going to write is count occurrences. And we're going to take in a symbol and an S list, and we're going to count how many times that symbol appears in the S list. So if we take in the symbol A, we're going to count how many times A appears in this S list, and we see that it appears 1, 2, 3, 4, 5 times, so it should return 5. So let's get started writing this. We're going to follow those 5 steps from the previous 2 lectures. So hopefully you'll have a screenshot of that or them written down so you can refer to them. Step 1, write the function. I'm going to just start with the SList function, and then we'll write symbol expression next. Step 2, separate our productions. So if we our SList is null, then we have an empty SList, and if not, we have a full SList. So empty, full, and step 3 is to break apart complex or compound data. So we have some compound data we can break apart in the full case. You have the car of the S list and the cutter of the S list. Step 4, recurse where you can. So we want to recurse on this. Now, in this case, we want to count occurrences. This is a symbol expression. The car is a symbol expression, so we're going to call the symbol expression function on that one. And on this one, we'll separate this onto 2 lines. We'll call count occurrences on the S list. And now remember, it's going to take in 2 parameters, the symbol and the S list. So we have to give that 2 parameters, and this count occurrences will probably take 2 parameters as well. So now we're making the recursive calls. So we're done with step 4, and we're moving on to step 5, the hard step of answering the right question, combining results together. So if we have an empty S list and we want to know how many times a symbol appears in it, well, hopefully we know that answer. It doesn't appear at all. Now, in this case, we are trusting that these functions do the right job. So this counts how many occurrences appear in an S list, and this counts how many appearances of this symbol appear in a symbol expression. So we have 2 numbers coming back. How do we combine them together? Well, we add them. And there's our first function done. Now, the one thing that I wanted to emphasize was the fact that in this case, we're returning a number. So make sure that we're returning a number here. And the fact that we're returning a number tells us that our combination needs to use a operator that operates on numbers. We won't cons these together because that operates on lists. I've got started writing the other function that operates on symbol expressions. And step 1, write the function. Step 2, separate the production. So is our symbol expression a symbol or is it a list? So if it's a symbol, we have this case, and if it's another S list, we have this case. So step 3, break apart compound data. We cannot break apart a symbol, and there is an operator or a function that already counts the occurrences in an S list, so we wouldn't want to break that apart. We'd want to move on to step 4, where we count our occurrences of our S list before, so S and just the symbol expression. Because now we know the symbol expression is an S list, we can call count occurrences to count how many times this symbol appears in the S list. Now, if it's a symbol, we want to know if it's the symbol that we're looking for. So let's do that. and fix our indentation a little. And so if equal our symbol that we're looking for, and the symbol expression that we now know is a symbol, if they're equal, then return 1. If they're not equal, what do we want to return? 0. So if the symbol expression is a symbol and that symbol is equal to the symbol we're looking for, we can return 1. If not, we're going to return 2. If it's not a symbol at all, it must be an S list, and count occurrences will count those. So just to make this a little more concise, we can put this all in one line because there's not a lot of code there. And there we go. And let's go ahead and test this and see if we get the right answer after we run and put in all of our parentheses to finish that function out. Of course, we need to call it define instead of def. And we see that it now works. The next function we're going to work on is flatten. What flatten does is it takes in an S list, so the same BNF we've been working with, but it'll flatten it into just a full list of characters instead of having lists inside a list. So a full list of symbols instead of having a list of symbols inside of the list. So each member is a symbol. So let's get started working on that. We have a flatten here, and it's going to take in an S list. We're going to do these 5 steps pretty quick. So I've written the function. Next, we want to separate out our productions. Do we have an empty symbol list or a full symbol list? So is our S list null? If so, then we have an empty one. And if not, we have a full S list. The next step, step 3, is to break apart our compound data. So we just take the car of the S list, and that gives us a symbol expression, and the cutter gives us the S list. And step 4 is to write the recursive function. So this one is going to flatten a symbol expression because the car is a symbol expression. And the next one is going to flatten our S list out because the cutter is an S list. Okay, so we've done step 4. Now it's time to do step 5. And what we're going to do with this is we're going to use an auxiliary variable as an accumulator. This is going to collect our results. So I'm going to add one more parameter. We're going to have an S list and another parameter which we could call results. To make it really clear as I explain it, I'm going to call this symbols so far, which is a pretty long name. So I'm going to just do SSF for short. Symbols so far, and we need to make sure we call flatten aux and pass it the symbols so far. And in this case right here, we're probably going to need to pass that along as well. So and then we need to combine the results still. We're still working on step 5, but it might help if we move on and do steps 1 through 4 for this flatten SE. So let's go ahead and define that one. And it is going to be a function that takes in an S list and the symbols so far. And I just noticed that is spelled up there. So 2 parameters we're going to have, instead of call that an S list, we'll probably call this a symbol expression. And same steps, we need to separate, do we have a symbol or do we have an S list? So if this symbol expression is a symbol, so there we go. If it's a symbol, then we know we have a symbol. If not, we know we have an S list. So we'll just recurse on this, flatten aux, with our symbol expression, and we're going to pass along the symbols we've seen so far. All right, now we're at the point where we're on step 5. We're going to try to solve this all together, and we want to collect all of the symbols we've seen into this auxiliary variable that we pass in. All the symbols we've seen. When we see a new symbol, we collect it onto here. So in this case, this is the only case where we see a symbol. If we look at our BNF, the only place we see a symbol is right here, and that is this case that I'm highlighting. So we can see that this is where we want to collect a new symbol. So how do we collect it? Well, this is going to be a list of symbols, and I have a symbol. So I have one element, and then I have a list. So to add an element onto the front of the list, we just cons the element onto the list. Now I am going to return that. So I'm not going to do, and that's what I'm doing already. This if expression, if it's a symbol, it's going to return whatever this returns. So I'm going to return that. In this case, I'm going to return whatever flatten aux returns. So I'm going to return the list with a new symbol added into it. Now, this is a little hard to see as we're writing it, but when it all comes together, it'll work. If we have, now we still need to combine the results for this. This function's done, but we still need to combine the results for this. If we have an empty list, there's nothing in it, then what symbols have I seen so far in this list? Now, I actually can't answer that because I haven't seen the full list. I've just seen the empty list. But they answered it for me. They told me how many symbols they've seen so far. So when I get to the end of a list, I'm just going to return the symbols that what I was told were the symbols they've seen so far. Now, in this case right here, we have a symbol expression. We're going to go check and collect all the symbols in the symbol expression. And we're going to add them into the symbols we've seen so far. In this case right here, he's going to go check the S list and get all the symbols he's seen and add them into the symbols that they've seen so far. So one thing that we can do right here is just append the two answers together and return that. But if you go to the reading, append is actually, it has to search through the entire list. It's kind of an expensive operation. So what I'm going to do instead, now I believe that append will work, but what I'm going to do instead is take this entire function call that collects all of the symbols in the cutter, and I'm going to pass it in for the symbols that we've seen so far. So, and then we don't need to do that anymore. And we are actually done with our function. So let me show you this working, and then we are going to explain this in a little more detail. So let's run this. And I don't have the original list anymore, but we'll go ahead and flatten a complex symbol expression or an S list. And of course it's saying that flatten isn't defined because I called mine flatten aux. This is what I expect. So what I need to do is create an interface function that will get everything started. So we'll define flatten to be a function that only takes one parameter this time, an S list, and it will call flatten aux with the S list that it was given, and it's going to pass in an empty list to get us started. So we haven't seen any symbols, so this very first time we're going to get an empty list. Now we'll see this all work together if I can spell define right. And we could see we flattened out the list. It's just a flat list with all of these taken out. So let's go ahead and we're going to be able to explain this, I'm going to do a lot easier or a smaller S list example that we can use to try to explain. So I'm just going to go A, B, and D. And we're not going to reuse characters just so that we don't get mixed up between them. So we can see that flatten definitely flattens that out. So let's go ahead and explain exactly how this list got flattened into that list. Now, one thing that will help in understanding is seeing the box and pointer diagram of our simple example that I just ran. And we can see that there is a list with 3 elements, 1, 2, 3. And the basic way that this function works is by each time it's called, the car gets taken off and the cutter and separated from the cutter. So the first time the function call is called, A is the car, the rest is the cutter. The second time the function is called, this is the car and the rest of this is the cutter. So the car is actually this list inside of the list, and this is the cutter. And then the third time the function is called, D is the car, and empty list is the cutter. And we actually call it a fourth time when we get all the way down to the end, and that becomes the empty list, and it's our basis case. So each time flatten aux is called, we move an element from the list, and we end up calling it 4 times going through the main list. Now, how do the symbols get collected? Well, each time the car is a symbol, it gets concatenated onto the symbols so far. So at the basis case, we return an empty list, and it keeps getting, and that empty list gets passed in from flatten aux into flatten SE. So the first time it's an empty list that we add D to it. The next time we end up adding B and C. So just take it by faith that flatten aux flattens these out and returns us a list with C and D that gets concatenated onto D. Well, how did it get concatenated onto D in the first place? Well, that's because the symbols so far got passed in a list with D in it through this right here. Now it might be a little bit hard to see, but I encourage you to step through these functions step by step. Maybe run it in your head, write down the function name, say I'm calling flatten aux with, this is my S list, an empty list as my symbols seen so far. And then run through the code, figure out what everything is, what it will do next, and then write down on a piece of paper and run through the code manually. And that's the best way that you can go to understand this. If you want to make it the example a little bit smaller, you can, and that way you can kind of wrap your head around everything that's going on. Now, one way to help you run through this code is to use the debugger in Dr. Racket. Just click this debug and you'll get a window up here. You can run your command and click enter, and you can see now we've called flatten aux and it knows the variable, and we're going to call flatten aux and see the arrow points to where we're at, and you can just click step. And now we're up here. It lets you know what the variables are. The S list is A, C, D, B, D. And you can keep stepping through this one step at a time and look at what happens to the variables. It's telling you what function it's going to call next and what the variables are at that time. And you'll see that the symbols so far will start to collect our variables. Now, as we see here, I've stepped a little ways. You notice that the A is gone, and that's because we're in a function call. Let's keep stepping into this. And now we're at a point where the symbol so far has collected D in it. And if you saw that all the variables got collected up. Now I encourage you to do that yourself on your own. So I'm going to end this lecture video here so you can run through this code on your own. Take as much time as you need to see it go through each step.